Okay, so let's continue with our next video in our practice exam question series for the AWS Certified Developer Associate exam. So question number 51. A developer has a legacy application that is hosted on premises. Other application hosted on AWS depend on the on-premise application for proper functioning. So one application is hosted on on-premises, and there are some other application which are on AWS. But the which some application depend on the application which is running on the on-premise as well for the proper functioning. As maybe someone is a microservice architecture, so let's suppose six microservice, five microservices running on AWS. Sixth one is on premises, but all five might need to connect with the one which is running on premises. In case of any application error, the developer want to able to use Amazon CloudWatch to monitor and troubleshoot all application from one place. Right. So they want to, if there is an error, they want to see the logs in the CloudWatch at one place. So what the application which are running on AWS, definitely they can send the logs to the CloudWatch logs. But what about the application which is running on premises? So how can the developer accomplish this? Install AWS SDK on the on-premise server to automatically send logs to CloudWatch. Wrong. If you just normally install AWS SDK, as an example, just Boto 3, pip install Boto 3. By just installing Boto 3 on the server, it is not going you to send the logs to the CloudWatch logs. You need to update your code as well. So it is by installing SDK on your on-premise server, it is not going to send the logs to the CloudWatch logs. Download the CloudWatch agent on the on-premise server. Configure the agent to use IAM credentials with permission for CloudWatch. That's correct. So one option is you can like update the code, but that is not an option. The second option is like you can install the CloudWatch agent, and CloudWatch agent is a kind of a daemon service which is going to run at the backend. It's going to monitor your application and going to send the logs to the CloudWatch. Upload log files from the on-premise server to Amazon S3 and have CloudWatch read the files. No, they said like whatever the application running on premises, they that is going to upload into S3. So log the file into some file that will go to S3, and then the CloudWatch read. So very complicated. Upload log files from the on-premise server to EC2 instance. No, we can directly send to the CloudWatch log. That's it. Either by modifying the code, but modifying the code is not an option. So other option is just install the CloudWatch agent. So B is the correct answer. Question number 52. An Amazon Kinesis data firehouse delivery stream is receiving customer data that contains personal identifier information. So an Amazon Kinesis data firehouse delivery system is receiving customer data that contains personal identifier information. The developer needs to remove pattern-based customer identifier from the data and store the modified data into Amazon S3 bucket. So this is a like a real-time data system. No, not a real-time. That is a Kinesis data stream, but this is a Kinesis data firehouse delivery stream is receiving customer data which contains some personal information like maybe date of birth or address. We need to store this information to S3 bucket, but before we need to store the information to the S3 bucket, we need to remove this information. Basically, the information which is like PII information, like maybe date of birth, phone number, kind of things. So how you can do that? So basically, you need to write some code, right? Some code which is going to do that. So Kinesis Firehouse delivery stream is going to support Lambda. So, and that Lambda you can attach with that. So then that Lambda is going to upload to the S3 bucket. So let's go through the option. Implement Kinesis data Firehouse data transformation on an AWS Lambda function. Okay. Configure the function to remove the customer identifier. Set an Amazon S3 bucket as a destination. Looks correct. Launch an Amazon EC2 instance, set the EC2 instance as the destination of the delivery stream, run an application of the EC2 instance to remove. No, you don't need to run the application on EC2. You can directly run into your Lambda. Application means the particular piece of code which is going to remove the personal information. Create an Amazon OpenSearch service instance. Set the OpenSearch service instance as the destination of the delivery stream. No, you don't need OpenSearch services. Create an AWS step function workflow to remove the customer identifier. As the last step in the workflow, store the transform data into Amazon S3 bucket. No, you don't need a step function for the orchestration purpose. You can just normally create a Lambda function and attach it with Firehouse, and that's it. So A is the correct answer. Question number 53. A developer is using an AWS Lambda function to generate avatars for profile picture that are uploaded to an Amazon S3 bucket. So you are uploading some pictures into your S3 bucket, and Lambda function is generating some avatar of the profile pictures. The Lambda function is automatically invoked for profile picture that are saved under the S3 prefix. The developer noticed that some pictures use the Lambda function to timeout. The developer wants to implement a fallback mechanism by using another Lambda function that resizes the profile picture. So maybe some pictures are very huge in size, and to process those pictures, the Lambda function is getting timeout. So let's suppose you have 100 pictures into S3 bucket, and out of 90, it has processed successfully, but remaining 10, maybe those are large in size, and for that Lambda get timeout. What you want is you want a fallback mechanism. Fallback mechanism is as soon as something is going to fall, a plan B, you can say. So you want to implement a fallback mechanism to resize those remaining 10 images so that you can again uh, generate an avatar. So how you can do that? So if any image is failing or any error is coming, what you can do is you can send those images to the destination, and in the destination you can trigger the Lambda. So that is the best approach. But let's see. Set the image resize Lambda function as a destination of the avatar generator function for the event that failed processing. Definitely correct. So you have the S3 bucket. As soon as something is uploaded into S3 bucket, the Lambda is triggered. If it is success, then it's fine. But if it is fail, that Lambda is going to send the images to the destination, and in the destination you have the another Lambda which is going to resize your profile picture, and that is going to be triggered. And when you set the destination, you have the option whether you want to run that Lambda only for the fail processing or only for successful processing. So we can set only for fail processing. So A looks correct. Let's read other option. Create an SQS queue. Set the SQS queue as a destination that an on failure condition. Configure the image resize Lambda function to pull from the SQS queue. No, like unnecessary you have to run a Lambda which is maybe continuously or on the schedule basis uh, poll from the SQS queue even though you don't have the any error. So looks incorrect. Create an AWS step function state machine that invokes the avatar generated Lambda function and use the image resize Lambda function as a fallback. No, correct, wrong. Create a simple notification service topic. Set the SNS topic as a destination of failure condition, and then subscribe the image size. No, you don't need to do this option. We can normally, because as soon as anything is going to fail, you need to trigger the another Lambda. So you can normally set the destination. You don't need any other services unnecessary. So A looks correct. Question number 54. A developer needs to migrate an online retail application to AWS to handle an anticipated increase in traffic. So they want to migrate an online retail application to AWS. The application currently runs on two servers, one server for web application, another server database. So if you move to the AWS, so you need one service which hold the database and one service which hold application. The web server renders web pages and manage session state in memory. Okay, the database server hosts a MySQL database that contains another order data. When traffic to the application is heavy, the memory usage for the web service approach 100% and the application slow down. The developer has found the most of the memory increase and performance decrease is related to the load of managing additional user session. For the web server migration, because till this point what he mentioned how it is running locally or on premises. Now to migrate, the developer use EC2 and then the auto scaling group and then the load balancer to manage the load, which is totally correct. What additional set of changes the developer should make? So one additional changes is like they need some database because we have the another layer database. Another is that because he's maintaining some kind of managed session state memory. So some kind of elastic cache we need. But let's read. Use an EC2 instance to host the SQL database. No, there is no. We already have the serverless service, so you don't need to install EC2 instance for the SQL database. Use Amazon Elastic Cache for Memcache to store and manage the session data. Use RDS for MySQL DB instance to store the application data. Looks correct. Use Elastic Cache for Memcache to store uh, and manage the session data and application data. No, Memcache should not be for the application data, just for the session data. For the application data, it should be RDS. Use the EC2 instance store to manage the session data and RDS for SQLDB. Uh, no, because because you are running the uh, auto scaling, so multiple EC2. So you have to make sure instance store are always in sync across the EC2. So better the elastic cache. So B looks correct. Question number 55. An application uses Lambda function to extract metadata from files uploaded to an S3 bucket. The metadata is stored in Amazon DynamoDB. So one application using Lambda function to extract metadata from files which is uploaded into S3 bucket, and that metadata is stored in Amazon DynamoDB. The application starts behave unexpectedly and the developer want to examine the logs. So if you are running Lambda and if you want to check the logs, where you are going to check the logs? CloudWatch. So where would the developer find the logs? Should be CloudWatch, not in S3, not in Cloud, not in DynamoDB. Simple question. Question number 56. A company is using an AWS Lambda function to process records from an Amazon Kinesis data stream. The company recently observed slow processing of the records. A developer noticed that the iterator age matrix of the function is increasing and the lambda ran duration is constantly above normal. I think this is the repeated question we earlier covered. So a company is using AWS Lambda function. So we have the Kinesis data stream where some data is coming, and then we have the Lambda function. Lambda function is consuming the records from the data stream. Company observes slowness and this iterator age matrix. Iterator age matrix means number of records into the data stream is increasing. So what you will do? So basically, if you want to improve the processing from the Kinesis data stream, you can increase the number of shards because the data stored in the shard. If it is currently one shard, you can split into to two or four or five shard. So increase the number of shard. Along with that, you can increase the memory of the Lambda function because as soon as you increase the memory, the CPU power will be increased. So how you can increase the processing speed? Choose to increase the number of shards. Definitely true because as soon as you increase the number of shards, you can process the records in parallel. Decrease the timeout of the Lambda function. Totally wrong because Lambda already taking more than normal. So decreasing timeout might reduce to result the timeout of the Lambda function. B is wrong. Increase the memory. Correct because as soon as you increase the memory, CPU will be increased. The processing speed will be increased. Decrease the number of shots. Totally wrong. We need to increase the number of shots for the parallel processing. Increase the timeout. No. So A looks okay and C looks okay. Question number 57. A company needs to harden its container images before the images are in running state. The company application use ECR as an so they are creating some container image and it is being currently stored into the ECR. And Amazon Elastic Kubernetes service for compute, and they are running the images on Kubernetes service and code pipeline that orchestrates the continuous integration workflow. Dynamic application security testing occur in the final stage of the pipeline after a new image is deployed to a development namespace into a EKS cluster. A developer need to place an analysis stage before the deployment to analyze the container image earlier in the CI/CD pipeline. So what is happening is they are running CI/CD pipeline. code pipeline basically, and they are creating the image, pushing into the ECR and deploying to the EKS cluster. And dynamic application security testing occur in the final stage of the pipeline after a new image is deployed. So when the image is deployed, after at that time they are doing the security testing, and during the security testing they figure it out. Uh, so that is totally wrong. Like security testing should be done before the deployment. That's why a developer needs to place an analysis stage before the deployment, which looks correct because any type of testing should be done before the deployment. So which solution will meet this requirement with the most operational efficiency? So what you can do is, because you are running the code pipeline, so within the code pipeline, you can add one more stage just before the deployment stage to run your security testing. So build the container image and run the Docker scan command locally. No, totally wrong because we are already using the code pipeline. Create a new code pipeline stage that occur after the container image is built. Totally correct because we need to add some stage into the code pipeline, and the best place is as soon as the image is built, and then scan it. Configure ECR basic image and scan on image push. Use an AWS Lambda for an action mode. Configure the Lambda function to check the result. Totally correct. Create a new code pipeline stage that occurs after source code has been retrieved from its repository. No, wrong. Because testing should be run whether there any vulnerability or not. We will find on the Docker image, not on the code. So they said as soon as the checkout has been done, and at that time you can create a stage. Wrong. We need to create a state as soon as the image is built because we are deploying the container image. So we need to find the vulnerability into the container image, not in the code. So B looks correct. Add an action to the deployment stage to the pipeline so that the action occurs before the deployment to the EKS cluster. You can do that, but it looks very late. Generally, the testing should be done as soon as the image is built. They said when you are just approaches to the deployment stage, at that time you add the action. Wrong. So B looks correct. Question number 58. A developer is testing a new file storage application that use an Amazon Cloud Front distribution to serve content from S3 bucket. So you have the Amazon Cloud Front, which is a global service which is serving the content from S3 bucket. The distribution access the S3 bucket by using a origin access identity. The S3 bucket permissions explicitly deny across to all other user. So S3 bucket permission is explicitly denied to all other user. The application prompts user to authenticate on a login page and user signed cookie to allow user to access their personal storage directory. So they said as soon as the user will time to login, a login page will be appear. The user will authenticate themselves, and then using the cookie, they are going to access their personal storage directory because they don't want to access the any other user directory. The developer has configured the distribution to use its default cache behavior with restricted viewer access and has set the origin to point to the S3 bucket. However, when the developer tries to navigate to the login page, the developer receives a 403 forbidden error. The developer needs to implement a solution to allow unauthenticated access to the login page. So they want, uh, because at least the login page should be populated, right? Because if you can't even access the login page, then how you are authenticate yourself? So developer want to implement a solution. Unauthenticated access should be granted to the login page. The solution must keep the private content secure. So how you are going to do that? Add a second cache behavior to the distribution with the same origin as the default cache behavior. Set the path pattern for the second cache behavior to the path of the login page. and make viewer access unrestricted. Yes. Keep the default cache behavior setting unchanged. Definitely correct. Because whatever the default behavior, what is the default behavior? Uh, that is explicitly deny access to all other user. User can access only their personal directory, and after the login, they can do the signed cookies. And the developer has configured a distributed user default cache behavior with restricted access, and that's set point to the S3 bucket. So you want this setting as is. The only additional setting you want is when the developer try to navigate to the login page, they should not get forbidden error. All right. So you should not change the default settings. All right. So you should not change the default cache behavior, but you need to implement a second cache behavior, uh, which is going to route to the login page. Add a second cache behavior to the distribution with the same origin as the default cache behavior. Set the path pattern for the second cache behavior to star. Wrong. You should not set the second cache behavior to the star. You should the path should be only for the login page, not for the star. Star means everything. And change the default cache behavior path pattern. No, you should not change the default cache behavior. B looks wrong. Add a second origin as a failover origin to the default cache behavior. Point the failover origin to an S3 bucket. Set the path primary origin to star. Totally wrong. As soon as you see the star, you should ignore that. Add a bucket policy to the S3 bucket to allow read access. Set the access resource on the policy here and the login page object in the S3 bucket. Add a cloud for distribution. So wrong. You should not change the like policy because it is clearly mentioned. The solution must keep the private content secure. So A looks correct. Question number 59. A developer is using AWS Amplify hosting to build and deploy an application. So they are using AWS Amplify. The developer is receiving an increased number of bug reports from users. So the developer says like receiving an increased number of bug report. The developer want to add end-to-end testing to the application to eliminate as many bugs as possible before the bugs reach production. Which solution should the developer implement to meet this requirement? So they are like deploying some application using Amplify, and the developer found that the user has reported so many bugs. So they want to implement a kind of a solution so that before deploying, they should do some kind of a testing so that they can catch the bugs before production. So basically, they can run some test. That's it. Run the amplify add test command in the amplify CLI. So there is no such command add amplify add test. Create a unit test in the application. Okay. Deploy the unit test by using the amplify push command. No. Add a test phase in to the amplify.yaml build settings. Totally correct. Because when you are deploying using the amplify.yaml, you can add a test phase uh, in the build because the test should be run into the build stage. Add a test phase to the AWS exports. No, C looks correct. Question number 60. An e-commerce company is using an AWS Lambda function behind Amazon API gateway as its application tier to process orders during checkout. The application calls a post API from the front end. The post API invokes Lambda function asynchronously. In rare situation, the application has not processed orders. The application logs show no error or failure. So it mentioned there is an e-commerce company which is using AWS Lambda, but the Lambda is running behind API gateway. To process the order during checkout, the application calling some post API. Post API invokes the Lambda, and some application has not processed the order. But when you see the Lambda logs, you have not found the failure. Even though Lambda is running, but when you check the Lambda log, you have not find the failure. So what should you will do? Inspect the front end logs For API failures, call the post API manually by using the request from the log file. No. Create and inspect the lambda dead letter queue. Troubleshoot the failed functions or reprocess the events. Okay. Inspect the Lambda logs in Amazon CloudWatch. No, because it is clearly mentioned the Lambda application logs which they already checked, which has no errors. So there is no need to check the logs again. Make sure the caching is disabled. No, they have nothing as such mentioned. They are using the caching. So D is wrong. Inspect the front end logs. No, you should not inspect the front end logs. So the best approach is, because some orders are not processed. So what you can do is you can implement the dead letter queue. If the Lambda is not processing the orders, those can move to the dead letter queue so that you can reprocess the events again. So B is the correct answer. So that's it. That's the end of the video, and thank you.